Hello everyone. On this video we will be going over Rolle's theorem. Okay, so starting off, what if we let f of x be continuous on the closed interval from A to B and differentiable on the open interval from A to B. Oh, let me kind of straighten up that B a little bit there. Okay, so if those stipulations are met, we know that if f of A equals f of B, then there is at least one C value in that interval, that open interval, where f prime of C is equal to 0. Alright, so just to kind of draw you a picture so you can help visualize it, okay, let's draw our x and y axis. Let's say you have a piece of your graph here. Let's say I'll move it over. Okay, so let's say this point here, and we move that over a little bit more so these can be equal. Let's say these two are equal. So let's say this is your A value and this is your B value. So f of A is equal to f of B. So they're saying if you have those two are equal on some open interval, then at some point between them, you'll have a zero slope, or f prime of C is equal to 0, where this is your C value between them. Alright. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to a quick example. Alright, so let's say, for example, we want to find the value of C in the interval -9, -1, guaranteed by Rolle's theorem for g of x is equal to -2 x squared minus 20x minus 15. Alright, so just a side note, we know that g of -9 is equal to g of -1 because they're both equal to 3. So if you plug both of them in, you'll get 3. Alright, so to solve this, we know that this is continuous between -9 and -1 because there's no value you can plug in between those that would somehow give you some undefined value. So we know that g of x is continuous and differentiable So it's continuous on the closed interval and differentiable on the open interval. So that means we can use Rolle's theorem. Alright, so since we know that g of negative 9 is equal to g of negative 1, there exists a g prime of c that equals 0. Alright, so all we have to do is find it. So we know that g of c, we're just using our g of x up here. So g of c is equal to negative 2x squared. Oh, negative 2c squared. Sorry about that. 2c squared minus 20c minus 15. Okay. So now we just have to find our g prime of c. Okay, so that would be negative 4c minus 20. Okay, so now that we have our derivative, we have to find g prime of c equals 0. Okay, since this is our g prime of c, it's basically telling us to find where negative 4c minus 20 equals 0. Alright, so if you add 20 to both sides and divide by negative 4, you end up with c equals negative 5. Okay, so we know just by that the point negative 5 and g of negative 5, whatever, if you plug it in, whatever value you would end up with, is the point on the graph where the slope is 0. Okay, now it's not saying it's the only point where the slope is 0. On this particular graph it is, but they're saying that this is a point where the slope is 0. On other graphs you could have more than one point. But all Rolle's theorem tells us is that once those stipulations are met, then we know for a fact that there is at least one, not just one, but at least one. And we were able to find that c value where the slope is 0. Alright, so hopefully this made sense, and I will see you on the next video.